Thanks, Henry, invite me, to join this, webinar. So I change a little bit about the topic. I will talk about, the construction. So how, we're using, technology to enable, green, or what we call the zero carbon and circular economy. Yeah. Okay, so anyway, this is just a summary. Construction actually is a greatest contributor for carbon emission and also energy consumption. I think in the world now, so we need really to do many things, not only something, to reduce our carbon emission and also the energy wastage. So how do we do it? So I think the key aims for circular economy is first we need to reduce the material that we use on the building and also
Let's give you an example.
Okay. First, reduce, the material, by reuse, recycle, and also minimize, the consumption of material. And also, we want to, optimize, the resources that we use, during on the construction stage. Yeah, that means we need to reduce logistics and also try to build many things, as much as possible in the factory, not on the construction site. So that means we can reduce, also the pollution. Yeah. So how do we do it? So here is
how we want to work with the
video.
Models. The client document their requirements in a database that the building according to the client's requirements. The building is modeled by numerous digital objects. One of the objects is a door. The door is chosen from an object library in the design software. The design software automatically adds information about the position of the door. The consultants add information and requirements for dimensions, material, color, fittings and surface, thermal transmittance value. The architect positions the BIM in a digital map to enable the contractor to know exactly where to build the school. The project team uses the BIM to coordinate the disciplines and to analyze project cost, analyze life cycle costs, analyze energy performance and other environmental impact factors for environmental certification. The BIM is sent to the local building authorities to get a building permit. The authority's BIM server automatically checks the building and approves the project. The contractor uses the BIM to plan construction, to communicate with building product vendors to get quotes and environmental information on all the building components, including the door, make their own cost estimation. The contractor accepts the best offer from the product vendors. Automatically, all product information is added to the BIM, while the real door is transported to the building site. The property caretaker identifies the door with his handheld device and registers the damage. All the door information is available at hand, and he can order new parts on site. The glazier repairs the door. The event and all information about the new parts are registered in the BIM. This is how we make the building industry work more efficient and produce more resource-efficient solutions. We need to document and share all information by one open format using one standardized terminology. That is building smart. Building smart for a sustainable building industry.
Okay, so this is a short movie, but I think it's easy for everybody, if you are not in the construction industry, at least have idea, how, the new approach, of using, technology to build the building. So I think, what we're talking about, the green BIM is the most important thing is information. That means, okay, we at the first beginning, we lay down all the requirements for sustainability, how to rebuild, the circular economy, all these kind of things. And then, of course, compare, the alternative, to suit, our requirement. And then we, group all the people together, so that means, okay, we set up a supply chain that, can enable the circular economy. And also, of course, at the end, all the information are captured. And what we're talking about is about the material passport. That we can ensure, okay, the carbon footprint, not only on the starting of the design or during the construction, even on the demolishing. How do you demolish the building is also one of the challenge on the construction. So here actually is the diagram about how we do the construction waste management. So at the first beginning, of course, we support all the stakeholders from designer, from material engineer, contractor, client, and also the FM operator. And what we build actually through the BIM is the construction information. And the BIM information actually is enable, actually is all the stakeholder, through the supply chain. So that means, okay, on the, as we mentioned, on the starting age of the design stage, and then you build up, the requirement, and then on the construction stage, what we're talking about, the process. Then okay, how do we minimize the energy and the wastage, during the construction, and after that is okay, how do you operate the building? So that means, okay, we have 7 different database, but actually it's in the same page. It's about the asset information, about the asset database of the waste, and also how do you recycle all the material. So this is the idea and also the framework of the system. And okay, so that means, okay, what we want to do is, okay, to optimize the asset performance, fulfill all the project stakeholder requirement, and also for the customer excellence and sustainability. So the role of the BIM actually is, you can see, design for circular economy, verify, the material, and also through the simulation, we can understand fully, optimize the energy consumption. And also, of course, resolve all, the sustainability of carbon emission issues before we start, the construction. And also we manage, the whole life cycle. So that means, okay, we have the product data. That means, okay, what is the element we use, in the construction, and also the process, the environmental process. Okay, how do we reduce, the logistics, for example, to cut down, the carbon emission. Even, okay, we can work from home, not go, on the site, to complete, the project. So here is, a real example of, how we're using, through the cloud computing, we can collaborate together in a virtual environment to design, for example, this is, the commercial building. So through that, everybody, every stakeholder, can address, of course, the design, but also, to manipulate, the material. Yeah. So that means so everybody can give, the comment or even update the material database, so that at the end, we can all are in compliance, with the carbon emission or, the wastage, requirement, all this. So everybody, can participate, all around the world, in any place, in any time. So this is, the newest can say technology. Yeah. And on the other hand, here is, another video to show you how we can, put inside in the information, on the BIM, yeah, to certify, through a platform.
We can check modeling properties. Everything starts actually with requesting the right properties. Let it be any topics, let it be any kind of BIM use cases or any phases of the project. First, we have to request the right properties, and then that's something that we will be able to check against and modify each other. We have 3 modules in the application: Docs, Scope, and Verify. Starting with the Scope module, that's where we can define the different use cases. That's on the horizontal axis. Information model. Of course, we can create any kind of BIM use cases, any kind of targets that we want to, or purposes that we want to reach with our models. And we can start requesting modeling components with respective geometry and also properties per these different use cases. This is where I see any kind of sustainability or circular economic properties being listed. Environmental product declarations or life cycle analysis or any kind of material mapping information added as a requirement at a certain use case for these elements. These properties can be customized and can be custom defined. So by clicking on this manage button, we can add and create any kind of new properties that we want to assign to these building components. And if there is a high amount of properties, we can of course always import them from external sources. What are those requirements that we expect on certain use cases? These are displayed with these check marks. Once these are defined, then the models are being generated. We can switch them to the verify module, and in the verify module, we will import the models that are being generated and can automatically check against the requirements that are set. So if we take a look, for example, at the asset information model, we will see the certain elements and opening up this small arrow, we can also see the details. So we can see that 25 instances of this ceiling element group is actually fulfilling the requirements, meaning that the material requirements had certain values, the brick, vinyl, and so on and so on. And in these instances, they were added properly. While in other cases, in this example, fire rating, shown with an orange color, and surface color is even worse, that those properties are completely missing from the model. In total, that shows a 29% completion of these modeling components, and we know exactly what kind of information it is. Again, these information requirements were defined in the scope module, and we could easily add any kind of custom requirements together with their values, with their expected values, again, EPDs, LCAs, and so on.
Okay, so after that, actually, also, because, the model include all the components. So that means it's easier, for us, to output all the schedule and also the material property or etc., for the procurement or even for the operation and maintenance. So all this information are fully, embedded in the model. Here is an example, of, for example, a facade, including, the support and also the glass. So you can see all the diagram, all about, the cost, the model, the drawing, the documentation, and all, you can consider, all the life cycle, information can be, put on the same place or on the same page. Yeah. So, and then after that is, okay, how about, when, you do the fabrication or construction? Actually, we can also, using the simulation to understand how, the things are put together. But not only for that, but when you demolish or do the end maintenance, and then you can understand how we could do, do it properly. That means we can classify all the material that we can reuse or we can recycle, or we need to pay some money for the landfill. So it can all well managed, through the simulation, and then you design everything from the start up. It's not at the end, and then it can save a lot of our resources. And this is the important component when we are talking about when we are developing a circular city. Yeah. So this is I can say through the BIM we can address all the complete life cycle on the first beginning until the building demolished. Or actually I can see in the future there's will be less new building will build, but more for building for renovation, because we want to reduce the material. So this is we need to keep track all the life cycle data. So this is the idea of the technology. So this is the key benefit of the sustainability, and also the impact of the value. We save time, we save money, we save money, energy, and also, also I think the point is also improve, the quality, and the quality behind is, the quality of life. I mean, this is the ultimate goal, for us, to address, the circular economy. Yeah. So this is, very short, I can say opening introduction about how the technology can use on the construction and enable, to build up our smart city. Yeah. Thank you.
Thank you.